Good afternoon, everybody. My name is Klaas Hierega of SurfNet, and I'm very honored to chair the session about mobility. It's actually the first of two sessions. This session will be oriented towards solutions for the last mile, or as we nowadays like to call it, the first mile problem. The session tomorrow morning at 9, so don't make it too late, at the gala this evening, will be about specific solutions for access to wireless LAN. So be there as well, please. I was asked to make a couple of announcements. The main announcement is be in time for the gala evening tonight. Some of you who showed up, like me, a quarter too late at the previous reception know that they will close the door on you and you will not be allowed in. Tonight the same thing will happen, so be there. The other thing, I was specifically asked to ask you to shut off your mobile phone, and actually mine is still on too, so I will demonstrate it. Because it can interrupt all kind of things like the microphones, etc. We have 3 speakers, actually 3.5, I should say, since Nick, sitting next to me, is going to be speaking to you for a couple of minutes. But we start with Josh Howlett of the University of Bristol. Josh is a biologist by training, and that probably explains why he has come up with this very intricate scheme of building out of nothing a very nice way of protecting resources and most of all wireless LAN. So with this introduction, I would like to hand over to Josh for his presentation.
Okay, thank you, Klaas. Can everyone hear me okay? At the back? Yep, good. Right, as Klaas said, my name is Josh Howlett, and this is my colleague Nick. I was responsible for the technical development of the Nomadic network. Nick's been running the client side, user support. I'm going to talk for about 20 minutes at a very fast pace about the technical side, because there's an awful lot of it, and then Nick will talk about the user side. So, on we go. 1999 and year 2000, we saw a whole raft of new technologies coming online. We had the ratification of the 802.11b standard in the summer of 99. In the Bristol area, we had new broadband technologies, cable, ADSL, and so on. And we were also seeing an increasing number of laptops, students and staff, and this is measured in the hundreds of laptops in the university at least, even at this time. By 2001, we didn't feel we could ignore these strands, so we wanted to offer 3 different services. The first was wireless access. The second was wired access. By that, I mean someone coming along and plugging into a network point and getting a network service. And last but not least, VPN access from off-campus, for example, from home, from a conference like this, or from anywhere. Is everyone familiar with the concept of a VPN before I go any further? Because I'm going to be talking about VPNs an awful lot. If you're not familiar, stick up a hand and I'll talk about it briefly. Okay, fantastic. We had some very rigorous requirements. We wanted a solution that was very integrated. We want wired, wireless and VPN in one box. It had to be secure. There's no point doing it if people are going to hack in, find holes. So we wanted AAA and encryption. It had to be easy for users. If it's not easy for users, your users will root around you and find other solutions that might not be very secure. It had to be easy for us to run and support. We don't have much resources like any university. It had to be future-proof. I've talked about broadband, wireless, people wandering around campus. We don't know what's going to happen in the future, but what we wanted was an architecture that was flexible enough to allow us to add new types of network access technologies in the future. For example, Bluetooth looked like one of these things at that time. Resilient and scalable, sort of classic enterprise features that we really needed. So failover, so we can keep offering a service, load sharing, so we can scale up in an organised fashion. And last but not least, cheap or preferably free. As you might have guessed, particularly going by the last requirement, we came to a decision fairly quickly to develop our own solution, which is a Linux-based router called a Roam node. Development started in January 2001. A pilot started 6 months after that, which we had about 100 users on. And we continued development with that until about a year later, September 2002 last year. And we're now up to over 900 users. Okay, theory of operation. Each user is assigned to what we call a home service. And a home service is effectively an IP network, so for example a departmental network, plus a bunch of, a number of other bits of ancillary information, such as a DNS server, a Win server, other types of bits that are useful for a user's service. And a home service is, like I said, assigned to a target network. So the physics home service is mapped onto the physics VLAN. The engineering home service is mapped onto an engineering VLAN, and so on. And a Roam node can host one or more or any number of home services. So, for example, in this example, physics and engineering map onto Roam node 1, biology maps onto Roam node 2. And that is hopefully illustrated in the diagram at the bottom. A user connects to his home service using a VPN. This is all pretty straightforward. So in the instance of someone at home with a broadband connection, connects to his ISP, he then starts up his VPN connection. He gets allocated an IP address from whatever network is mapped onto his home service, and he's got an IP address from within the university. However, life is not so simple if you're wandering around campus with a laptop. In the previous example, I was talking about an ISP that was allocating the initial IP address. In the instance of roaming about, we don't have an IP address with which to start the VPN session. So we allocate this initial IP address using a protocol called Pppoe, which stands for PPP over Ethernet. It's simply a way of encapsulating a PPP stream within Ethernet frames rather than within serial. All the PPP sessions run across an isolated, logically or physically network called a roam LAN. It's isolated so that no one else from outside can get inside. It's not possible to route from the roam LAN to the rest of the campus network. That's one of the critical features of the security. The user is allocated an RFC 1918 address, and an overlay network is constructed dynamically between the roam nodes on the Nomadic network that offer the service. We'll skip the last bit, it's boring. Okay, so here we have Einstein, who's associated with an access point on the roam LAN. Like I said earlier, all the other access points or switches or any of the edge network access devices will be on the roam LAN. He starts up a Pppoe session with the roam node. Instantaneously, an IP and IP tunnel is brought up across the campus network from whatever roam node he's got his Pppoe session with to whichever roam node is hosting his home service. And then through that goes his VPN session, and he gets an IP address. It's easiest to think about this in terms of roles. In the instance where the user has a Pppoe session, that roam node is called the local node because it's the node that is local to him. And the node that is offering the home service is called a home node. It's just an easy way of thinking about it. So we have a slightly more complicated example here. Einstein and Marconi are wandering around on a roam node that is also offering a home service. And likewise, Darwin is wandering around near a local node that is also offering his home service. Therefore, no IP and IP tunnels are required. As Marconi and Darwin have a chat over lunch somewhere, at the bottom roam node, an IP and IP tunnel is brought up back to their own respective home nodes. Therefore, they're able to get a VPN session back home. Likewise, Einstein goes for a wander, another IP and IP tunnel comes up, he gets back home. And again, Darwin and Marconi go for a wander. Now, only one IP and IP tunnel is needed. So the system of IP and IP tunnels is constantly shifting in a very dynamic fashion. And the advantage of this is that it doesn't require any administrative input. It's all done automatically by the Roam nodes, completely invisibly, both from the user's perspective and from the administrator's perspective. The user is authenticated twice, once at the local node, once in the home node. This might sound a bit over the top. It's got some very good advantages. The first is that at the local node, when we authorize at the local node, it means that we can authorize on the basis of the user's physical location. And authorization at the home node means that we can authorize on the basis of the network that the user is attempting to connect to. For example, a biologist will be authorized to connect to the biology network, but not to the engineering network. And likewise, an engineer should not be authorized to connect to the biology network. Encryption. This is a function of the VPN protocol that we're using, which is PPTP, point-to-point tunneling protocol. And that uses MPPP at 40 or 128 bits. The actual VPN protocol is independent of the architecture. We could use any other type of VPN protocol, but we went for this simply because Microsoft supports it on everything. Now, the Roam node itself is all open source software, runs on Intel boxes, wonderful, really cheap. Boots and runs from CD-ROM. It's an 8 megabyte ISO image that you can download from our website. Interestingly, a couple of wireless ISPs are currently looking at taking the image from the CD-ROM and sort of turning it into an embedded appliance for their own use, which is something which is quite interesting. All the management is via a secure web interface. So that's what it looks like. As you can tell, I'm a network engineer and not a web designer. And again, right, clearly this was first implemented at the University of Bristol where I work. Now, it was actually quite a demanding environment in which to build this because we have a very non-contiguous network at layer 2 across the campus, owing to a previous ATM backbone. So we have 5 Roam nodes. For authentication authorization, we're using a Microsoft Active Directory which stores all the users' credentials. This is, again, just an artifact because it's what the university uses anyway, so we just hook into it. The Roam node is actually vendor neutral. Anything that talks radius, the Roam node is happy to talk to, so you can use any kind of authentication backend. So, diagrammatically, that's the core of our network with a router and our backcall to Janet. We then feed out to layer 3 switches at the IP level. And then the VLANs are then taken out to the departments. At each layer 3 switch, we have a Roam node. And then into each Roam node, we trunk using VLANs, 802.1q encapsulation, all of the networks that we're interested in. So the networks that we want to offer a home service to, and the Roam LANs that we actually want people to physically connect to. Oh, and there's the edge infrastructure, so access points, so on and so forth. Quite a lot of other places are interested in using this. There are 5 other universities known to be piloting or implementing the Roam node. It's reasonably proven. We've got 900 odd users. It's very flexible, as I hope you've seen, and also it's free. The most advanced implementation is at the University of Wales, Swansea. It's nice to contrast Bristol and Swansea because they have a brand spanking new network which is contiguous edge to edge at layer 2, so they only need 1 Roam node. They also have multiple authentication databases. Unlike Bristol, we have 1 authentication database, they have lots at the departmental level. So they hand off authentication out of departments. It fits in very nicely into their existing infrastructure. Genome Campus at Cambridge. This is another interesting example. It actually consists of 3 separate, administratively different institutes with their own authentication backends, but they're all sharing much of the same physical infrastructure, the same canteens, libraries, offices, etc. And they're interested in this because it gives them an easy way of making sure that researchers and other people can wander about the physical infrastructure and still get a network service that is identical to what they'd get in their office. Right, the mobility aspects of the Nomadic network are quite interesting, so I'll just, my remaining time is more or less spent talking about this. How much time do I have, Klaus?
About 5 minutes.
Okay. Right, roaming at layer 2 is easy, very straightforward. It's handled by the access points. It's transparent to the Nomadic network. Roaming between access points that are connected to different roam nodes is a little different. As the user wanders out of range of the access point, the IP and IP tunnel, the VPN session, and the Pppoe session are torn down until the user reassociates with the next access point and the session starts up again. Another interesting aspect is roaming between different organizations. Here we have the same user roaming at home at organization A. He then goes to another organization. His authentication credentials, his username and password, is proxied back to his home authentication service using standard radius functionality. Assuming that the home organization says this is a valid user and is authorized, then the user is allowed to start up a Pppoe session, and an IP and IP tunnel is, yet again, set up between the local node and the home node. We've tested this successfully between the Bristol and Swansea campuses. And it's all based on trust relationships. It's all very obvious. We have essentially a roam node that we call X. Bristol trusts node X. Swansea trusts node X. Therefore, users can roam from Bristol to Swansea and vice versa without users having to make any change or alterations to their laptops. It's been designed explicitly to scale very well, and part of this is due to the hierarchical design which Radius allows. So you can have delegated management as you move down the hierarchy. So the user retains the same user identity and network identity, that is the same IP address, regardless of his physical location. The only management task that must be centralized is the IP space allocation for roamlands, that is the RFC 1918 address space. If any of that address space overlaps, then there's obviously potential for confusion. However, it's made a little simpler by the fact that it doesn't matter where you pick your address space out of the range. It doesn't have to be sort of contiguous chunks. It can be from anywhere, just as long as it's not overlapping. Like I said earlier, no need for management of the overlay network. It's created on the fly as users wander about the place. Resilience. This is quite an interesting and challenging area. You can now cluster roam nodes together into, as it were, virtual roam nodes. And this works both in the role as local node and as home node. So, for example, we have a couple of users here. They request a session, a Pppoe session. It just so happens that those two roam nodes says, yep, you can have a session with me. And the IP and IP tunnel is again set up to any one of the three roam nodes that are providing a home service for those users. Sorry. And again, the VPN sessions goes through. You can take out any of those roam nodes, well, one or two of them, obviously, and still be able to offer a service. The only part of this which I haven't yet completed, which is the most difficult bit, is being able to take a roam node out of a cluster without interfering anyone. But I hope to have that finished quite soon. Locating users. This again is quite interesting. Where is a user located? Why do we care? Lots of reasons. Provisioning. Where do we need more access points? Also, there's lots of potential for sort of quite intelligent web applications. If you go to this URL here, it will redirect your web browser to the website of the department that you're in. So, for example, if you go to the library, you type in that URL, you get the library catalogue. Another application, automatic selection of the nearest network printer. We have 30 or 40 public network printers around the campus that anyone can use. If someone has a desktop PC in their office, they're only ever going to use one or maybe two printers. If someone's roaming around campus, they may be using considerably more printers. So the likelihood of someone accidentally printing off their 500-page thesis on the AutoCAD plotter 20 kilometers away is quite large, and that's the sort of scenario that we want to avoid. So we're making essentially interfaces so that applications can plug into this and automatically tell the application what printer to print to. Future-proof. It's all based on Ethernet. Ethernet's great, here to stay. As long as your network access technology supports 802.3 encapsulation, then it's fine. So, for example, we now support Bluetooth via the BNEP PAN profile. Like I said earlier, we're currently using PPTP, but we could support others. The largest change that's likely to happen will be a migration to IPv6. Using RFC 1918 address space is obviously incredibly kludgy, untidy, not very pleasant. We want to move to IPv6. This, again, is just used for the roam lands. So you'll be able to tunnel your IPv4 user VPN session across the IPv6 address space. So it'll be transparent to the users and to the administrators. And now, at this point, I shall hand over rather breathlessly to Nick.
Thank you, Josh. I was responsible for taking the design and infrastructure that Josh has built and making it into a production service that we can actually roll out to our end users. And so that's been quite an interesting experience with some lessons which I'd like to share with you. When we were designing Nomadic, we did design it from the ground up to be supportable. And we have a service which is up and running now and has been since October. So we needed to support a broad range of platforms which are in use at the moment. Every Windows version from Windows 95 onwards, the latest Apple Mac versions, and Linux clients. So there were several decisions that were forced on us from that. We wanted something which would support all those versions with no licensing costs, so we had to use built-in or free software. We wanted to minimise the support effort required, so we wanted to make it possible for the users to connect themselves and to register themselves on the network. And as we wanted it to be easy for them, we decided to provide instructions and software in as much detail as possible. The network stack required on the client varies, depending on which of the different services they wish to connect to. If they're just making a VPN connection from off-campus into the university, then they just need PPTP support. If they're connecting to the roaming service, either the wireless service in our public areas like libraries and foyers, or the equivalent wired plug-in Ethernet service in those areas, they need both PPTP and also Pppoe support in the client. The Pppoe stack we used, it's very easy in the latest operating systems, where all the functionality is built in. But for the older Windows versions, we used a third-party piece of freeware called Pppoe to provide the Pppoe stack. The PPTP support, that's been built into all Windows versions for some time, which is why we chose to use it, to make it easy on the client side. But it does need patches on the older Windows versions to increase the encryption strength and fix a few bugs. The user interface, when a user connects to the Nomadic network, it looks like a dial-up networking connection. So that's quite important. It's familiar to the users, and it doesn't disrupt other network services on the system. So a laptop or desktop can be set up for Nomadic, and it won't interfere with any other network stack that's been set up on the system. The resources we prepared for the users, we have a website with detailed information and publicity about the service, an online registration form that they fill in if they wish to connect to Nomadic, which then interfaces with our authentication databases and prepares that for them. We have step-by-step connection guides for each operating system, which the users can follow through at a very basic level. We prepared a CD, which has any necessary software and operating system patches. And we provided support through our existing ResNet team. ResNet is our team who handle the student residences. And it seemed to be a similar fit. The difficulty in supporting student systems in residences, which are very diverse, and supporting personally owned student and staff laptops. The procedure that a user goes through if they want to connect, they register with the online form, they print out the documentation, they pick up a CD. That's only required for the older versions, but we have it for them if they need it. They follow those instructions step by step to connect up, and we hope they don't get to the last step, but if they do, we have support available for them in person, telephone and email. How usable is it? The most important measure is how many people connected successfully to the network with the resources we had prepared without actually having to come to speak to anyone in person. And most people connected up themselves quite happily and successfully on their own. But a minority of users did have problems connecting. In particular, the older Windows versions, where there are more patches that need to be installed, and non-English Windows versions. There wasn't anything intrinsically difficult about supporting non-English versions. It was just that there was a large diversity of systems that we had to deal with, and in particular, the operating system patches that were required for things like the improved dial-up networking client varied depending on the Windows version. So distributing all that software was trickier than it would have been just distributing it to English-only laptops. It takes maybe 5 or 10 minutes to set up a system if it has Windows XP, and maybe half an hour or an hour to set it up with one of the older Windows versions. But once it's been set up, it's then very quick and easy to connect in future. At the moment, we've got over 900 users using the service since we rolled it out essentially in October this year. And maybe between 50 and 80 people use the network, either the remote service or the roaming service, every day. And it's growing quite rapidly, 20 people or so signing up each week. And most of them connect successfully, but between 5 and 10% need some personal advice by phone, email, or in person before they get on the network. But that's comparable with some of our other services, such as our ResNet service, certainly when we first set those up. Who uses the service? It's very popular with staff who can access their files from home, and it's very popular with the students because they like to be able to use their own computer rather than a public computer room, as their own computer is more convenient for them. It's tricky to support these people compared with, say, supporting a typical desktop computer in a department. It's too far to visit the users, and there's a very diverse range of systems. You can't mandate a personal computer that somebody buys as a home system, so you have to support a wider range of systems. So we manage the expectations the users have, and essentially we provide less support, but for a broader range of systems, and we concentrate on providing very good self-support resources for the users. In future, there are some challenges. We'll have to support PDAs, and we don't do that as yet, and we have some ideas on how to improve things for very short-term visitors, like conferences. In summary, the Nomadic network's been very popular with our users and filled some definite, distinct needs that the users have. The support requirements are in line with our other services. It's quite low cost because the hardware is commodity and the software is free. It's straightforward to manage, and we've designed it from the ground up as much as possible to be secure and scalable. If you'd like to find out anything more about it, then all the information is available on this website, or you could get in touch with myself or with Josh. Thank you.
We have room for 1 or 2 questions. Karsten?
This all looks very familiar because tomorrow morning I will give the same talk again. But why did you use Pppoe for handing out the private addresses? What we call the standard architecture in Germany does it just using DHCP.
Pppoe has a lot of advantages. First off, it sets up basically a virtual connection between the local roam node and the client. So if you have a malicious user also on the same network segment trying to make a connection to that user, he can't because the target user tries to reply down the tunnel to the local node where the local node disregards it. So all users are protected from other users on the same network segment. There are also advantages such as if a lot of users, for example, don't have administrative rights on their laptops. They're just users. If you say you've got a static IP address that your administrators set you, and you need to change that to DHCP, you have to go to your administrator and say, can you change it to DHCP, please? But anyone can create a dial-up connection.
Yeah, I'm not sure I follow the first part because I'm not sure that Pppoe gives you any security at all.
It gives you security in the sense that no one can set up a TCP session with you. Whereas if you've got an address on the network with DHCP, then anyone can set up a session with you.
Thank you.
Anyone else? I think the gentleman from Finland was first, and I would like to conclude it with that question. I've talked before this session to all the presenters because they all have way too much slides. I now know how they are dealing with it. They just talk twice as rapid, but they all agreed to stay a bit longer after the session, so they are prepared to answer any other questions. But I don't want to take too much time out of the other presenters. So sorry, Jürgen.
Okay, about this PPP over Ethernet. When you start this PPP over Ethernet tunnel, do you use some kind of username and password there to open up this PPP session? And how are these secured?
Pppoe uses the standard PPP authentication mechanisms. For example, you can use anything that PPP provides. So you can use PAP, you can use CHAP, you can use, or in fact, what we use is MS CHAP v2, yes, it's secured in that fashion. Does that answer your question?
Yes, it does.
Thank you.
Okay, I'd like to thank the two presenters once again and give them a second hand, please. With that, we move on to the next presenter.